So far this unit, we've done a lot of simplifying radicals. For the sake of just simplifying, we haven't really done a lot with radicals, so today we're going to apply them, and we're specifically going to be applying radicals and stuff we've learned with radicals to finding missing side lengths of right triangles. You've done this topic before. Some of the radical stuff just might be a little bit more challenging than what you've seen in the past. So a theorem, which you do a lot of theorem work in geometry next year, and a theorem is just something that you can prove. So look ahead, get excited, geometry. But a theorem that you guys have seen before, done this in middle school, it uses radicals. It's called the Pythagorean theorem. And if you forget what Pythagorean theorem looks like, it is a squared plus b squared equals c squared. Now, I just mentioned that this theorem is used in right triangles, and realize that it can only be used for right triangles. So hopefully you remember what a right triangle is. It's a triangle that has a 90-degree angle. So I'm going to draw a picture of a right triangle down below here. So the right angle, we note that with a little like square in the corner. So that would be like my 90-degree angle. Now the sides in a right triangle have like different names. Okay, so the side that's opposite, which opposite just means across from. So the side that's across from the right angle is called the hypotenuse. And spelling doesn't count on any of this, but if I draw like an arrow away from the 90-degree angle, that's the side across from the right angle. That's my hypotenuse. And if you forget this, that's the side that we call C. So the hypotenuse is C, across from the right angle. This is the longest side of the right triangle. So good to know. Realize that the other two sides, so C is across from the right angle, the other two sides, doesn't matter which one is which. These are called the legs. One of them we're going to call A, one of them we're going to call B. Okay, so the only one that really matters is C. Once you pick that out, the other two are A and B. Okay, that's like the base information we need to know along with Pythagorean theorem. So let's kind of apply it to this first example. It says, find the length of the hypotenuse in a right triangle if the legs are 4 and 6 centimeters. Leave your answer in simplest radical form. This part is important. This means, and maybe this is where it differs from what you did in middle school. If the problem says simplest radical form, you cannot use decimals. Okay, you need to give me a radical answer, and I'll show you what we're talking about when we write our solution. If they don't give you a picture of the triangle, like the two at the bottom here, you should draw your right triangle. It's going to make the problem so much easier. So there's a right triangle. I know across from the right angle, that's C. The other two are A and B. And those are the legs, which, guys, they told me how big the legs were. They said one was 4 centimeters, one was 6. Does not matter which one you label 4, which one you label 6. Just know that across from the 90, that's got to be your C, which is what I'm trying to find, the hypotenuse. So I'm just going to use a squared plus b squared equals c squared, my Pythagorean theorem, to figure out the C value. That's what this formula is used for. If you're given two sides of a right triangle, you can use this formula to find the third side every time. So A and B are 6 and 4. So I'm going to plug those numbers in for A and B. That should equal C squared. I don't know C, so I'm going to keep that C squared. Now I just have to work this out, and I know that I should do the exponents first, order of operations. So 6 squared is 36, 4 squared is 16. Then I'm going to add 36 plus 16, that'd be 52, equals C squared. Okay, we've touched on this a little bit, but the opposite of squaring, so I'm not done until C is alone, so I need to get this squared out of there. So the opposite of squaring is square rooting. Square and square root cancel each other out, which would leave me with just C on the right-hand side, which is what I want. Whatever I do to one side, I have to do to the other. So square root of 52 is what I'm looking at. In middle school, guys, you probably would have done like square root 52 in your calculator. Maybe that's what you would have done. I don't know. 7.2-ish is not wrong, but they asked me to write the answer in simplest radical form. So I do not want to write a decimal. What I have to do is take square root 52, and I'll do it right over here, and I have to factor tree that down to get this simplest radical form. So here's kind of like what we've been doing where it comes into play. Maybe we'll do 2 and 26, 2 and 13. So I know, and I'll write my best answer down here, I know there's a pair of 2's, so a 2 would come out, and a 13 would stay under. So that's my answer, 2 radical 13. So same thing as this 7.2 decimal, it's just written in simplest radical form. Okay, so you got to read the directions real clear on there, how they want you to write the answer. Yay! And I'll warn you guys, you literally do this exact same thing in geometry next year. Okay, so I want you guys to try number 1. It's pretty much like the same as what we did up here, except this time you're trying to find B, one of the legs. So you would just set up your Pythagorean theorem differently, but you would go about it kind of the same way. If you want to watch me do number 2 first and then go back and do 1, not a bad idea. So the first thing I do, and notice I want to write it in simplest radical form again, I just want to find this missing side x. You have to figure out which side is c before you go crazy with setting up the formula. So across from your right angle, that is c, 5 radical 13. The other 2 sides are a and b. It doesn't matter which one's which. So maybe I'll just call x a, 5 radical 7b. So I'm going to plug it in. C has to go by itself on one side. So this Pythagorean theorem would look like this. I'd do x squared plus 5 radical 7. Put that in parentheses. That's going to make a difference. I'll show you. So I've got to square that side, and that should equal c squared. Okay, you've got to be really careful. So this is a little bit more complicated than the first example because there are radicals being used to label the side lengths. Obviously, x squared stays x squared. But when I do 5 radical 7 squared, you can type it into your calculator, but you have to be careful with the parentheses. So you actually have to have like 2 sets of parentheses there. And then square it, and it equals 175. So if you plug it in exactly like I just did, cool, your calculator will get that for you. But we can't always rely on our calculator. So squared means times itself. So you need to do 5 radical 7 times 5 radical 7, which using what I've learned so far, that would be 35 radical 49 right there. When I come over here to the right-hand side, I have to do the same kind of process. 5 radical 13 times 5 radical 13. I can multiply the 5's out front, and I can multiply the 13's inside. But then, guys, you can take this another step further. So the square root of 49 is 7. Not square root of 7, just 7. So this is really just 35 times 7, which is, shoot, not 35. I was going to say, wait, I did something wrong. Too bad you can't yell at me and tell me I made a mistake. 5 times 5, yeah, pretty sure that's 25. Not 35. Hopefully you caught that before I did. Anyways, this would be 25 times 7. So that's just 175. Which was what I got when I plugged it in using the correct parentheses. So if you have this calculator, I'm okay with you plugging it in like that. That's fine. But we should be able to do it by hand. Same thing over here, guys. The square root of 169 is just 13. So this is really just 13 times 25, which is 325. So just be really careful with squaring those radical expressions right there. Your goal is to solve for x, so I need to kind of do a little work here. I gotta subtract the 175. Not the prettiest work, I'm running out of space, but that would be 150. And then you gotta square root both sides to get x by itself and get rid of the squared. And here's where they say, write it in simplest radical form. You have to factor tree this down. Let's see if I can squeeze this in. I could do 25 and 6, 3 and 2, 5 and 5. Okay, so out front, I got a pair of 5s. Underneath, 3 and 2 would both stay, so that would be 6. Okay, on the back, same idea, except read the question carefully. This example says, find the area of this triangle. Give your answer in simplest radical form, and they want me to write the answer rounded to the nearest tenth. Same answer, just written 2 different ways. Okay, think to yourself, how do you find the area of a triangle? If you don't know, it's half base times height. A triangle is half of a rectangle, so that's where the half comes from. Now you got to think, well, what 2 sides are the base and the height? Well, they're the perpendicular sides, or the ones that make this right angle, so I'm not the hypotenuse. I don't want to use that side. So I need to do half times 15 times whatever this x value is. I need that before I can write the answer. Okay, well, you got to step back and say, oh, it's a right triangle, and I have 2 side lengths. I just need the third. So I can use Pythagorean theorem to find x, and then I can find the area. So Pythagorean theorem, remember, across from the right angle, that's C. The other 2 are A and B. So if I set up Pythagorean theorem, I could do x squared plus 15 squared equals 21 squared. Do your exponents first. 15 squared is 225, 21 squared is 441. It's nice when I don't have radicals involved in that. 441 minus 225 is 216, and then I would square root both sides to figure out what x equals. If you're not sure if 216 is a perfect square, you can always check it. And it's not, so here's where I want to factor tree this down. Otherwise, I'm never going to get the simplest radical form. So let's see, 216 divided by 4, we can do 54. 54, I could do 9 and 6. So 3 and 2, 3 and 3. All right, let's see here. X, I can pull out to the front a 2 and a 3. 2 and a 3, so that's going to be 6 on the outside. And then this 3 and 2 would both stay underneath, so 6 on the inside. Okay, so that's my x value. Now I can use that to do 1/2 base times height. Okay, watch this closely, and this is something, again, that we teach in geometry, so you'll need to know this exact same process, but you've got to write the answer 2 different ways. Most of us would probably be okay with the rounded answer. That's where you can just type it all into your calculator. 6 squared root 6. Notice that the radical opens up parentheses automatically in your calculator, so you just want to close it. So if I just type that into my calculator, that's the rounded answer. And rounded to the nearest tenth, that's 1 decimal place. So I would say 0.2. That would be, we won't even worry about writing the units. Units squared technically, but oh well. The simplest radical form, you have to multiply all of this. Basically, guys, you leave the radical out. There are no other radical numbers, so I can't multiply that radical 6 with anything. So I'm going to multiply all of the numbers in front of the radical. That'd be 45. And then I just have to stick the radical 6 at the end of it. So those would be the area of this triangle, just written 2 different ways. You're going to have to do this exact same thing on the exam. So you got to show that you can do that, write the answer both ways. Okay, last problem, and I'm going to do it for you. So same idea, I want to use Pythagorean theorem. Weird, I'm just finding a part of one of the side lengths, but I know if I have 2 side lengths given to me and it's a right triangle, I can use Pythagorean theorem. So across from the right angle, that's C. The other 2 guys are A and B. So I'm going to set up Pythagorean theorem like this. And I'm going to put parentheses around each side length, since there's like kind of 2 parts going on there. So here's where it's great if you know how to plug this into your calculator. The second you don't know how to do it without your calculator, you're going to get stuck because there's an X in there. So think to yourself, what does it mean if you square something? it means you times it by itself. So I have to do all of these times itself. Isn't this fun? Okay, so let's see what I end up with. You can multiply things on the outside. You can multiply things on the inside. So x times x would be x squared. Okay, now think about simplifying radicals. X squared is x times x. So there's a pair of x's, which means one x would come out to the front. So the radical really goes away, and this just equals 4x, which is kind of nice. When I square this second side here, I can multiply things on the outside, and I can multiply the 6's underneath. But guys, the square root of 36 is just 6. Proof in the calculator. So this is really just 9 times 6, which is 54. So far, so good. When you square this last side length, that would equal 16 square root 25. Again, the square root of 25, though, is just 5. So this is just 16 times 5, which is 80. So this is actually really nice. Now it just ended up being like a pretty straightforward two-step equation. So I would just subtract 54. 4x equals 26. And then I would divide by 4. Which this is going to be a decimal, but that's okay. Let's make sure we did our math right. Yep. So 6.5.